In previous lecture, we had discussed about the socket and RPC in client-server communication. Now in this lecture, we will understand some of the issues which is related to RPC protocol. In the RPC protocol, we find some of the issues like while communicating one process with another process which is reside in the another computer over the network, there might be some issues we are getting. So we will understand what are all those issues and how they are resolved. Now, coming to the issues and how they are resolved, the first issue is the difference in data representation on the client server machines. So, when we talk about the client server machines, irrespective of their configurations, uh, the both the computer client and server can communicate with each other, and the processes can exchange the messages with each other through the RPC. But the issue is when the data represents on the client and the server machine, there might be a different data representation in both the machines. For example, 32 bits integer. So some system known as the big ending, which use the high memory address to store the most significant byte, while other system known as little ending or little endian stores the least significant byte at the high memory address. Now this is the issue what we are having in remote procedure calls. Now in the client server, if one system is representing 32-bit integer, another computer is representing 64-bit of integer. So this is the difference in the data representation on client server machine. To resolve this issue, we have RPC system which having a machine dependent representation of data. Means the RPC protocol which defines the machine independent representation of data. To represent such independent uh, representation of the data in the client server machines, there is one such representation known as external data representation. So XDR is used to represent the data. So that this is the XDR is the machine independent representation of the data, so that the client and server can understand the data, what the transformation or the what kind of data is taken place between the client to server, server to client, because the XDR is the external data representation. So irrespective of this 32-bit 64-bit of data representation in client server system, so XDR is used so that the client and server both can be a machine independent, both can understand each other's language. On the client side, parameter marshalling involves converting the machine dependent data into XDR beyond they are sent to the server. Now, what happens in the client side, the parameters are marshalling and converting to the machine dependent data into external data representation before they are sent to server. Means we are marshalling and we are converting the machine dependent data of the client system to XDR, external data representation, so that after the conversion from machine dependent to XDR, we are sending to the server. Now on the server side, the XDR data are unmarshaled and converted to the machine dependent representation for the server. Now again, when the server receives this XDR data, so that is unmarshaled, right? So machine dependent data is marshaled and converted to XDR. XDR is received by the server side computer, and now that data are unmarshaled and converted to the machine dependent representation for the server. Now again it is converted to machine dependent representation for the server. So again it is converted to the machine dependent language. So now the server can understand this machine dependent language. So in this fashion, with the help of XDR, we can represent the data in client and server machines. So for marshalling the data and converting the machine dependent data into XDR in the client side, and the same XDR is received by the server side, and that is unmarshaled and converted to the machine dependent representation for the server, so that the server can understand whatever the client is sent. So in this fashion, the difference in the data representation on the client server machines are resolved. Now we have another issue, like whereas the local procedure calls fails only under extreme circumstances. Now in the local procedure calls, means in one system, if processes are calling each other or sharing a common memory and communicating with each other, they will fail in extreme circumstances. And RPC can also fail, or it can be duplicated and executed more than once. As a result, a common network error. We can get a common network error. So to resolve this, there is a OS which ensures that the messages are acted on exactly once between the client and server, so that we can eradicate creating the duplicate of that message, right? So exactly once means exactly once the message is sent between the client to server, so we cannot execute more than once, and we can't get any kind of network error if it is sent and received by the server. Rather than at most once, means only once the data is sent, and if we are getting the reply from the server, again we may send the next message. But for the same message, until we get the reply from the server, we won't continue with sending the message. So most local procedure call have the exactly once functionality, but it is more difficult to implement. Now with the standard procedure call, some form of binding take place during the link, load and execution time, so that a procedure call name is replaced by the memory address of the procedure call. The RPC scheme requires a similar binding of the client server port. But how does a client know the port number on the server? Neither the system has full information about the other, because they do not share the memory. Now for this kind of binding, we have a solution, like the binding information may be predetermined in the form of fixed port address. So the issue is the standard procedure calls some form of binding take place during link, load and execution time of the procedure calls. So it is replaced by the memory address of the procedure call. So RPC scheme requires similar binding of the client server port. Means during the linking, loading and execution time, the procedure call name is replaced by the memory address. So how this RPC scheme requires a similar binding of the client and server. But here the question is, how does a client know the port number on the server if the memory address of the procedure call is replaced, right? So neither the system has the full information about the others because they do not share the memory. So what is the solution for this? The solution is the binding information may be predetermined. So when both the computers are connecting with each other, the link is established between them in the client server architecture. The binding information may be predetermined in the form of fixed port addresses. At compile time, an RPC call has a fixed port number associated with it. So now you can understand, while compile time, the RPC call has a fixed port number which is associated with it. Once the program is compiled, the server cannot change the port number, right? It cannot change the port number of the requested service. Okay. And also there is a binding can be done dynamically also by Rendo's mechanism, which is also called matchmaker. So typically an OS provides a Rendo's, which is also called matchmaker, and daemon on a fixed RPC port. So daemon is a service which listen all the incoming packets from the client side. So a client then sends a message containing the name of the RPC to the Rendo's domain requesting the port address of the RPC. It needs to execute, the port number is returned, and the RPC call can be sent to that port until the process terminates. Means this matchmaker, which is called Rendo's, so this is the daemon on a fixed RPC port. So once the compilation is done, so it cannot change the port number. So server cannot change the port number, and a client then sends a message containing the name of the RPC to Rendo's daemon requesting the port address of the RPC. It needs to execute, right? It needs to execute, and the port number is returned, and the RPC call can be sent to that port until the process terminates. Means the RPC call can be sent to that port, means the client port. So until the process terminates means until the client execution gets over. So this is how the system can have the binding information, and this binding information is predefined by the fixed port address, and at the compile time the RPC call has a fixed port number which is associated with it, so that it cannot change the port number. And we use the matchmaker also, so that the binding can be take place between the client and server, and during the link load and execution time the procedure call cannot be replaced by memory addresses. Now with this diagram we will understand whatever we have studied so far, the issues and the solutions. So this diagram will tell you about how a client and server can communicate. So you can see there is a client, there is a server, and we have a message. So this is the execution of a remote procedure call. So how the RPC calls can be executed remotely. Now from the client side, user calls the kernel to send the RPC message to procedure X. Now user is calling the kernel to send the RPC, remote procedure call message to procedure X. Now kernel sends the message to matchmaker to find the port number. So we are sending to rendezvous, that is the matchmaker, to find the port number from the client side. So this is sent to server. Now request is sent to server by the kernel of the client computer. So kernel sends the message to matchmaker to find the port number. Now you can see from client to the server. Okay, so request is made from the client to the server, and the port is the matchmaker. So matchmaker will assign a port. So matchmaker will find the port, fix the port, and send back to the client. Okay, so here reference is address for RPC X, means the requesting for the address for RPC X. Now the matchmaker receives the message, looks up the answer from the server side, and matchmaker replies to client with port P. Now the reply is from server to the client, and the port is the kernel. So return back to the kernel port from the client side. To the client side. And there is a reference RPCX port P. So port P and RPCX. The RPCX is the client side and the port P is from server side. Now the connection is established. Thereafter the kernel sends the RPC. Now it is sent from the client to the server, and the port will be the P. So P port will receive the contents at server side. So the content is listened or received by the all the incoming data which is listened by the daemon. So daemon is listening to port P, receives the message from the client, and daemon processes the request and sends the output. So it is sending the output after processing the message. So who is sending it? It is from the RPC, right? From RPC to port P. To whom? To client. It is sending from port number P to client, and client's port is kernel port. Okay, kernel port. So what it is sending? It is sending the output. Now the kernel receives a reply or reply message and passes it to user. So in this way, this remote procedure call client server can communicate with each other. So these are the services what we can acquire or get from this RPC service in the operating system. So this is all about the issues in the RPC and how they are resolved. Hope you understood this concept. We will meet in the next chapter. Thank you for watching.